By placing a small microcomputer inside your car's center console and keeping the cables cleanly routed out of sight, you bypass the manufacturer's software restrictions. This configuration enables three specific features. It routes data through an uncapped cellular connection, serves a remote desktop to the car's native browser, and synchronizes audio with the vehicle speakers. To build this, you need three pieces of hardware. Step 1 is a Raspberry Pi 5. Step 2 is an iPhone with an unlimited cellular data plan. Step 3 is a standard USB cable to link them together. On the software side, the Pi needs to run Raspberry Pi OS. Specifically, it must run an X11 windowing session. The Wayland display server will not work for this display pipeline, so the installation process will switch the system over to X11 for you. You also need two external services to make the remote desktop secure. First, a domain name that you own, managed through Cloudflare. Second, an active email address, so the system can register an official Let's Encrypt TLS certificate. Assembling these exact components allows the hardware to circumvent the car's internal network checks and the cellular carrier's hotspot throttling. The result is an independent mobile workstation that runs entirely on your own terms. The first technical hurdle is getting the vehicle's built-in browser to connect to the Raspberry Pi. Modern car browsers, like Tesla's Chromium build, have strict private network access checks that block direct connections to local IP addresses. This image shows a domain settings dashboard inside Cloudflare. To trick the car into trusting the local connection, you must create an A record for your custom domain and point it exactly to the IP address 198.51.100.1. This specific testnet range bypasses the browser's security block. There is a critical failure point here. You must disable Cloudflare's connection proxy for this record. The traffic cannot pass through Cloudflare servers. It must remain entirely local. Set the toggle to DNS only. Next, generate a Cloudflare API token. Scope this token strictly to editing the DNS settings for your specific zone. The Pi will use this token later to prove it owns the domain and request a valid security certificate. By pointing a public DNS record to a highly specific local IP address, you ensure when the car asks the internet where your domain is, the answer points right back to the Raspberry Pi in your center console. With the DNS configured, transition to the Raspberry Pi desktop to input those Cloudflare credentials. Open the config.env file. Here, you will input the API token you just generated, your custom domain name, and the specific Wi-Fi credentials you want the Pi to broadcast for the car to join. Save the file and execute the primary installation script. This script automatically deploys the necessary software modules, including KasmVNC, which is the engine that serves the Linux desktop environment to a web browser. While the script runs, it securely contacts Let's Encrypt in the background, using your Cloudflare token to generate a valid TLS certificate. Once the certificates are verified, the script initiates a final automated reboot. This single script bridges the raw hardware and the network configuration, setting up a fully encrypted, headless remote server that boots up automatically whenever the car provides power to the USB ports. Now we link the upstream internet connection. Connect the iPhone to the Raspberry Pi using a standard USB cable, and toggle on the personal hotspot feature in your phone settings. Cellular carriers typically enforce strict data caps on hotspot usage. They detect tethered devices by tracking the time to live, or TTL, of your outgoing data packets. Looking at this diagram, we see how the Pi handles those data packets. Before sending the data to the iPhone, the Pi software intercepts the connection and artificially rewrites that TTL counter to exactly 65. As the packet leaves the microcomputer and passes into the smartphone, the phone applies its natural internal processing. It subtracts 1 from the counter, dropping the TTL down to 64, before transmitting it to the cell tower. 64 is the exact TTL value generated by native iPhone applications, so when the cell tower receives the data, it categorizes the heavy desktop traffic as normal mobile phone browsing. It routes the packets into your unlimited data bucket rather than your restricted hotspot quota. This precise packet-level manipulation at the egress point is what provides the mobile station with uncapped bandwidth, utilizing your phone's primary cellular plan. The network is ready. Inside the vehicle, open the Wi-Fi settings and connect to the local network that the Pi is now broadcasting. Next, open the vehicle's built-in web browser. In the URL bar, type in the custom Cloudflare domain you configured earlier. Because of the Cloudflare A record and the Let's Encrypt certificate, the browser loads the KasmVNC desktop securely. You will see a valid HTTPS padlock in the corner, confirming the connection is trusted by the car. The final step is audio synchronization. Using the touch interface on the car's screen, open the custom Bluetooth GUI on the Pi desktop to pair the vehicle's audio system. This diagram illustrates why device class spoofing is required here. The vehicle software expects phones to handle their own media, so it often rejects A2DP audio streams from devices identifying as phones. By broadcasting the Pi's Bluetooth specifically as headphones using class ID 0x240404, it forces the car to automatically open the high-quality audio channel upon connection. Combining a localized, secure DNS network with a spoofed Bluetooth audio connection embeds the external hardware seamlessly into the car's native interface. At this point, the system is fully operational. High-bandwidth media tasks, web browsing, and synchronized audio all run flawlessly through the vehicle's hardware without hitting carrier data limits. Because it's a full Linux environment, you can expand its capabilities. By plugging an MS2109 or MS2130 HDMI capture stick into the Pi's USB port, you can route video from gaming consoles or streaming boxes directly onto the car's display. A second expansion module supports wireless Apple CarPlay or Android Auto. Adding a CarLinkit USB dongle allows the Pi to clone and serve a localized CarPlay web app right over the same interface. Bypassing carrier limits and internal routing protocols means the car can now run hardware and software outside of the original factory environment, effectively acting as an open-ended workstation.